Hello students, welcome to Spectra Education Academy. In this video, I am going to explain two more long answer answers of two more long answer type questions from the chapter waves. Question is, explain the formation of stationary waves in air column enclosed in open pipe. Derive the equation for the harmonics, frequencies of harmonics produced. So first start writing the answer. Open argon pipe is a pipe with both ends are open. A sound wave is sent into the open pipe, which is reflected at the open end of the pipe due to pressure difference and also since the molecules, or you can say air particles, molecules of air are free at free ends or at the ends of the pipe, antinodes are formed. Okay. So in order to get the equation for the frequencies of harmonics, let us try to have stationary wave. This is open pipe producing stationary wave in such a manner that to have one loop, one antinode, node and antinode. Therefore, so what you can write is the stationary wave is formed. This is case 1, you can say. The stationary wave is formed. Stationary wave is formed in open pipe. To have two antinodes at the ends, and one node in the middle, and one node and a node in the middle. Okay, right. So within the length of the pipe, two antinodes and one node is formed. So therefore, this is going to be distance between node and antinode is lambda by 4. Similarly, this is also lambda by 4. So within the length of the pipe, lambda by 4 plus lambda by 4. This will be 2 lambda by 4. So lambda by 2. Then, so you call this the equation 1. Next, the relation between speed of sound, frequency and wavelength, or V is equal to F lambda. Since F is for fundamental frequency, substitute here V is equal to F you are looking for, lambda is 2L. So therefore, F is equal to V by 2L. This is called as fundamental frequency, fundamental or first harmonic. Next, that now the stationary wave stationary wave is formed in order to have three antinodes and two nodes. How? Three antinodes and two nodes. So like this is once again open pipe. So antinode, antinode, antinode. So this is once again node. So within the length of the pipe, L is equal to the gap between node and antinode. So it is lambda by 4. So this is lambda by 4. And node is lambda by 2. This is lambda by 4 once again. So therefore, lambda by 4, middle lambda by 2, and lambda by 4. So therefore, 4 is LCM lambda plus 2 lambda plus lambda. So therefore, 4 lambda by 4. 4 and 4 get cancelled. So L is equal to lambda. You call this the first equation. Then once again, speed relation between speed of sound, frequency. This is first overtone or second harmonic, and wavelength. So we call this is L1, lambda 1. So therefore, V is equal to. So this is going to be F1, lambda 1. So lambda 1 you got L. So this is F into L. So you can write F1 is equal to V by L. So in order to get in the form of the fundamental frequency, you multiply and divide with 2. So this part will be again the fundamental frequency. This is second harmonic or first overtone. Next, moving to. So the stationary waves. The stationary wave is produced in order to have 4 antinodes and 3 nodes. Then within the length of the pipe. Then, so this is the open organ pipe, open end. Yeah. So antinode, this is node, this is antinode, this is antinode, this is antinode, antinode. So this is lambda by 4. So this is lambda by 2. This is lambda by 2. This is lambda by 4. So therefore altogether, so within the length of the pipe, lambda by 4, lambda by 2, lambda by 2, and lambda by 4. So okay, so 4 is the LCM. So here is lambda, 2 lambda, 2 lambda, and lambda. So this is 6 lambda. L is equal to 6 lambda by 4. So therefore this is 3 lambda by 2. So now lambda is equal to, you call this is lambda 2. Lambda 2 is equal to 3L by 2L by 3. Now once again relation between speed of sound, frequency. This is 2, you call it as third harmonic second overtone, and lambda 2 is given by V is equal to F2 lambda 2. So F2 into lambda 2 is 2L by 3. So F2 is equal to 3V by 2L. So therefore, this V by 2L part is F, fundamental. So therefore, finally, the ratio of fundamental first overtone or second harmonic, first overtone, second harmonic, and second overtone or third harmonic is F is to 2F is to 3F. So the answer is 1 is to 2 is to 3. So moving to the explanation, the numerical given. Sorry, moving to the explanation for the second question. Let me read the question first. Yeah, how stationary waves formed in a closed pipe? Explain the various modes of vibration in a closed pipe and establish the relation between their frequencies. So the numerical given is already explained in the numerical session. So let us limit our explanation only to write the theory. First, closed pipe. An argon pipe which is closed at one end is called closed argon pipe. It's called closed argon pipe. Then next, after that, okay, consider an argon pipe which is closed at one end, argon pipe of length L, which is closed at one end, and open at other end. A sound wave is sent into the pipe. The waves are reflected. At the closed end. And the waves are superposed. So that stationary waves are formed. Okay. In order to get the frequency of the first harmonic or fundamental, the stationary wave is formed in order to have one node and one antinode. So antinode is in general formed at the open end only. Yeah, so this is the diagram. One end is closed and the wave is produced like this. Antinode is at the open end and the node is at the closed end within the length of the pipe. A wave of wavelength lambda by 4 is formed. So therefore L is equal to lambda by 4. So lambda is equal to 4L. So the relation between speed of sound, frequency, this is fundamental, and lambda is V is equal to F lambda, then F into 4L. So therefore F is equal to V by 4L. So this is fundamental frequency. So it's called this is equation 1. Now the stationary waves produced in the closed organ pipe, in order to have two antinodes and two nodes. Then, okay, once again you draw closed organ pipe, two antinodes and two nodes. So therefore, this is a node, antinode, then antinode. So within the length of the pipe, so there is lambda by 4. This is node and node lambda by separated by lambda by 2. So within the length of the pipe, lambda by 4 and lambda by 2 wave formed. 4 is LCM, lambda plus 2 lambda. This is 3 lambda by 4. So they call this is, we are looking for first overtone. Lambda 1 is equal to 4L by 3, equation 1. So once again, relation between V, speed of sound, frequency, first overtone, and lambda is given by V is equal to F1 lambda 1. F1 lambda 1 is 4L by 3 from the first equation. So this is going to be first overtone F1. You can also call it as second harmonic. Second harmonic or first overtone. So F1 is equal to 3V by 4L. Next, stationary wave, the third case. Stationary wave, the stationary wave is formed in order to have three antinodes and three nodes. Three antinodes and three nodes. Then, so draw the closed organ pipe in order to produce three antinodes and three nodes. So one antinode at the open end, one antinode in the middle, and one antinode here. So pipe is closed. This is node. So this is node, this is node. Then length of the pipe is once again capital L only. So this is going to be lambda by 4. This is going to be lambda by 2. This is going to be lambda by 2. So within the length of the pipe, lambda by 4 plus lambda by 2 plus lambda by 2. So therefore 4 is the LCM. This is lambda. This is 2 lambda. This is again 2 lambda. So therefore together 5 lambda 2 by L. So lambda 2 is equal to 4L by 5. Call this equation 1 in this case. Relation between speed of sound, frequency, this is you are looking for third harmonic or second overtone, and wavelength lambda 2. So therefore V is equal to F2. V is equal to F2 with lambda 2, 4L by 5. So therefore F2 is equal to 5V by 4L. So F2 is here. F2 is third harmonic or second overtone. So you can finally write the ratio of fundamental, next second harmonic or first overtone, second harmonic third harmonic or second overtone is given by first F. Next, this is going to be 3F, because you can write here also. You can write this is 3F. You can write this is 5F. So therefore, 1:1F and 3F and 5. So the answer is 1:3:5. Students, in the next video, I'll continue with the explanation of long answer type questions in the chapter current electricity. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.